Good evening, ladies and gentlemen. I'm going to talk about SQL tuning, and the common SQL tuning questions are: what is good SQL? What is bad SQL? Is full table scan good or bad? Is use of index good or bad? So I'm going to start with the optimizer. Uh, so now optimizer is a code that comes with database. So when you run a SQL statement, whether it's a select or update or insert or delete, Oracle has to make an intelligent decision on how to execute that SQL. Should we use the index or not use the index? So we need to understand the whole aspect of our optimizer, how it works, why it behaves in certain ways, and what can we do to tune or influence the optimizer. When the optimizer says I'm using index, we got to understand why it's using the index. Or it says I'm going to do a full table scan, and why is it doing full table scan? So that's very important. So what we can do to understand it, how it works, why it makes certain decisions, what are the parameters, what the DBAs can do, what the SQL developers can do, so it's making the right decision. Execution plans, we are going to talk about execution plans, statistics, manual versus automatic. So when we look at the execution plan, there are a lot of keywords like index scan, fast full index scan, scattered reads, nested loops, etc. So our job is to understand those terms, because if we don't understand those terms, we won't understand the execution plan. And if we don't understand the execution plan, then how can we tune it? So there are different statistics that goes into the making of execution plan. So what are those stats? We have system stats, we have database stats. So we look into those because they play a very critical role in SQL tuning. And finally, we got into the tools, the utilities, manual versus automatic. Manual meaning you monitor, automatic meaning Oracle self-monitors, it self-diagnoses, it prevents you the problems, it presents you the solutions. A lot of time when Oracle talks about automation, there are manual utilities like SQL Plus, TKProfs, Explain Plan, which will get the same job done. So we're going to start with database architecture. The main question is, what is caching? What is caching of data? What is redo? What is undo? What is database cache? So when you're asking to go and flush the cache, if you don't know what cache is, then you don't understand what you're doing. So that's the reason we want to get into a little bit of database architecture. Very important for you to understand is the different types of indexing. What is a shared pool? What is DB cache? Even though you don't have any control over that to design and configure, monitor, we need to know architecture, memory structures, the different processes that Oracle uses to run the database, and how we manage structures. One of the keywords that you must have heard is, as an application developer, is a term called instance. Instance is down, instance is up. So instance typically represent an access to the database. So as you see in the diagram, it's the Oracle database architecture overview. The instance has the SGA, which is the common place, and you have all the background processes for each session, and it's all connected to the database. The instance connects to the database for access. So what's the instant does? It gives global memory to all users. That's the PGA. So different users can come in, request some data that gets cached. So when another user looking for the same data, they can benefit from the cache data. Size of the SGA will be decided by your DBAs. You cannot bring the whole DB into memory. It's impossible. So what Oracle has to do, it has to kind of recycle things. As the customer's application demand, we load the things from the storage to memory. So all of the access that done from the storage is called physical reads. Physical meaning storage. Physical versus logical reads. Access to data in the memory is called logical reads. When we do SQL tuning, we are talking about physical reads and logical reads. So what is the difference? Memory being limited, so we can't keep everything in the memory. Oracle does what is called touch count method, what is also known as least recently used, most recently used. So every block in the memory has a touch count. So the blocks with the highest touch counts are called hot blocks, and the blocks in the memory with the lowest touch count are called cold blocks, or it's least recently used. So blocks, so Oracle really understands on a block level which blocks people are accessing and which blocks are people not accessing. So if we have to bring in some new information into the memory, it will decide on recycling the LRU or the cold blocks. But sometimes what happens is this: when Oracle says I'm going to recycle a block, it looks into the block and it's dirty. What is a dirty block? Dirty block meaning that the block was right from the storage and has been modified, but we never ordered back to the disk. So we can't just wipe it out. We can't just reuse it. It has to go back to the storage and then it's reusable again. So looking at the diagram, it's the background processes, and you have all these background processes in the connected to the SGA. And inside the SGA you have the database buffer cache, redo buffer cache, and the shared pool. So background processes. So some of the background processes like DB writer, log writer, system monitor, process monitor, check pointer, and the list goes on. The process are automatically created when your instance comes up. So if Oracle has to write some information from the memory back to the storage, it's done by the DB writer. If you make some changes to the database, those are called transactions. If those transactions has to be recorded somewhere into your reader, logs for recovery purposes, these are that's done by the log writer. Background processes keep Oracle up and running all the time. So if you see the diagram connecting to the database instance, you can see the user connecting to the database instance, and the user has user processes, and there's a connection, the instance, and SGA has the shared server dispatcher and user processes, server processes, and the user is executing a select statement. So connecting to DB instance, so if you allocate more memory, this cycle is slow. The recycle cycle is slow. If the memory is less, then the recycling is very fast. All of this is maintenance, more reads, more writes, more IOs. But again, bigger does not mean better all the time. So what we need to do is plan. Too little memory or excessive memory is equally bad. When users connect, we are going to start up some processes to represent them on the server, on the host. The piece right here is called the user processes. This one is called the server processes, and then we also have the background processes, but they're running already running. You don't talk to them. They know what needs to be done. So looking at the diagram again, Oracle database memory structure overview, and the SGA has the database buffer cache, redo log buffer, shared pool, large pool, Java pool, stream pools, and also the PGA, which is private for the user or the session, which has the background processes, servers, server processes. Shared global area, also known as SGA. But once you're connected, you have been allocated a process that will serve on your behalf. Background processes will serve the server processes. This is a shared area called SGA, shared global area. That means if one user brings some information into the memory and another user needs the same information, they don't have to go and read from the disk again. They can all share the information out there. It's a shared architecture. Now the SGA is not one piece, it's actually broken down into smaller pieces. The first one is database buffer cache, tables, indexes, partitions, materialized views. Anything that contains data will be cached into the database buffer cache. Redo and undo buffer. In technical terms, redo means recovery, unlike the English word redo. It's not doing again. I have a storage failure. I restore a backup. Now I have to apply all the last transactions so I can redo the transactions. The word redo is typically associated with recovery. So there is a memory allocated for the transactions that are running against the database. Redo log writer, log files. You initiate a transaction, that transaction gets recorded in redo buffer. When you commit, log writer will write the transaction from the memory into the storage. Why? Because 2 months from now, if I have a storage failure, data is restored from the backup and I can apply log files to it. And my database gets recovered and no logging is an option that's available. Then there is another term called undo. Now this is something that has to do with the command called rollback. You make a change, you don't like the change, and you can roll it back. How do we roll it back? Well, when we were making the change, we were creating undo images, and if you don't like your change, you type rollback. You're saying, Oracle, bring these undo images and undo what I just did. Where do we create undo? It's in the database buffer cache. Where am I creating the redo? Redo is getting created in the redo log buffer. So that's the difference between data cache and redo cache. Packages, procedures, function, all of the stuff is cached into the shared pool. Large pool, physical and logical reads. Large pools are typically used by backup, restore procedures, and parallel query. Now parallel query is something that's connected to SQL tuning. So if you're doing parallelism, then large pool will be used for that. Java pool is for Java objects. If you're running Java applications, you have Java files and you're trying to load a Java file that is not getting loaded. That means you have to go and increase the Java pool. DB cache, this is used for data. DB writer comes in. DB writer is writing to your what's called data files. When we read from the storage, those are called physical reads. When we read from the memory, those are called logical reads. So when we do execution plans, when we do SQL tuning, I got 1000 logical reads, I got 5000 logical reads, redo buffer. Redo means recovery again. There are certain operations that can run into no logging mode. Create index, no logging. Why do we do that? It goes really fast. What is the downside? If I recover my database, that index is unusable. I got to go drop and recreate it. So if you look at the diagram, commit processing example, this is a process, and the database data files, control files, redo files, and you see the SGA, which has the database buffer cache, redo log buffer, shared pool, library cache, and the DB writer, server process, user process, and the log writer. So let's see how the commit processing is done. Shared pool, more indexes meaning more redo, meaning more undo, less indexes, less undo, less redo, less indexing, no logging, which gives you better performance. So if I'm running an OLTP system and I'm running trying to maximize performance, one of the recommendation is that if I have indexes that are not getting used, make them invisible. So the difference between OLTP and OLAP is, OLTP is the transaction protocol where you make transactions, and OLAP is the application. It's for reporting purposes. What happens when we do a DML? When you do a DML, the first thing we do is bring the data into memory. Then we create undo. We also create redo and lock. Update employee, this is an update statement. So update employee set salary equal to salary plus 0.2 or 20%, which is 20 by 100. Then you get 100 rows updated. That's the message you get, and that means you went to the past state. We checked your permission, table names, column names, syntax, semantics, everything good, everything is good. Okay, we created an execution plan. We brought the data into memory. We created undo. We carried redo. Lock sign plays. DML is processed. If I don't like it, I can do a rollback. So there's no way to tell Oracle not to create undo data. We can tell Oracle not to create redo data, because without that we can't function. Or I can say commit. Commit meaning I'm happy with the change. I want to make it permanent. That is when log writer will record these changes from the memory into the log files. And eventually they will also be written out by the DB writer to the data files, but not when you commit. It happens later. When you commit a transaction, the log writer will write, DB writer will write it later. So every individual user and the sessions are assigned with individual PGE. SGA is the shared global area. However, PGA is memory that's allocated to these processes on an individual basis. So there is some memory that is private to every session. So you can also use the word P for private global area. What is that we have allocated memory to every process. And this is also connected to tuning, SQL tuning, because a lot of things in the execution plan, when we see them, you're using PGA. Ordered bys, group bys, sorts, all those are called operators. There are some joins that require sorting. Like there is a join strategy called sort merge. So when I see that in my execution plan, if it's taking too much of swaps on the storage and I keep increasing SGA. In that situation, I need to tell my DBA to start monitoring the PGA statistics, because my sorts are doing too many disk IOs, and the way you cut down disk IOs on sort is by increasing the PGA, and that's not SGA. So PGA is used in SQL operations like sorting, hashing, merging, like bitmap merging. So your DBA will decide what kind of strategy you want to follow. Automatic or manual, it can be decided on a session level, so they can decide overall strategy. Mostly the manual is freebies, and automatic you have to pay for it, and there's some licensing involved. Automatic memory management, if you look at the diagram, it's the SGA memory and aggregate PGA memory. The SGA memory will have the buffer cache, large pool, shared pool, Java pool, stream pools, and other SGAs. And in the PGA memory, aggregated PGA memory, you have untunable PGA, free private SQL areas. So sizing of each memory component is vital for SQL execution of performance. It's difficult to manually size each component. Automatic memory management automates memory allocation of each SGA components and aggregated PGA. Memory management. More memory meaning less physical writes, less physical reads, and anything that's physical takes more time. When you commit, log writer writes. When there's a checkpoint, DB writer writes. So when you run a SQL, whatever needs to be done behind the scenes, read, write, bring it into the memory, don't bring it into the memory, join it, sort it. These processes help indirectly but not directly. Now comes the memory management. One is manual, meaning you go through the utilities, you go through views, you look at the hit ratios, and then you make a decision. Database tuning is manual, and database tuning is automatic. So you have both options available. Every SQL goes through 4 phases: parse, bind, execute, and fetch. And if you combine it, it's all called the execution time. So if I can reduce any of those, overall performance goes up. So anytime you do a SQL tuning, you try to minimize how much time we spend in there. If you're OLTP, you'll be focusing a lot on this. If you are OLAP, it doesn't matter. It doesn't really make a difference. So if you look at the diagram, database storage architecture. You have different physical files, and it's control files, data files, online redo log files, parameter file, backup files, archive log, redo log files, password file, and there's also alert log, trace files, which will alert you. And there's MMON and MMAN and storage. There's a background process called MMON and MMAN. Memory monitor and memory manager. These tools can internally monitor your interval views and make a decision on that. Or you're running a backup job, let's create a large pool. Or you're done with the backup job, let's make it 0. Or you're running a Java routine, let's increase the Java pool. So these processes can auto manage your memory structures. So storage, we cannot run a system just from the memory. We need storage. Storage means persistent and permanent. Eventually things will be written out. So that's where the database comes in. Oracle definition of database meaning files. And there are different types of file. There's control file, which is used for internal purpose, checkpointing, SCN numbers, recovery. Data file is where your data is. Redo log is where your changes are. These are used for recovery. There are backups. There is copies of your logs on those tape drive. Those are called archive logs. As an application developer, database means storage. Database means files. So one of the jobs of the DBA is to make sure you don't run out of physical space in the files, and they keep resizing them and keep adding them, and there should be enough room to grow. So looking at the diagram, logical and physical database structure. Logical and physical, what's the difference? Logical is something that you cannot see from the operating system, and physical is something you can see from the operating system, like the files. Physical is data file, OS blocks. Logical, you have a schema which has database, table space, segment, extent, Oracle data block. So logical versus physical. The file that may be very interesting, that may be related to SQL tuning, is called temp files. How are they related to SQL tuning? And then database is always addressed in two forms. One is called logical and one is called physical. Table is logical, a file is physical. What's that? Because if I go to the operating system and do a ls-l in Unix, I don't see tables. In order to see how many tables I got, how big it is, who owns it, how many rows, I have to log on to database and run some query against a data dictionary and find it. File is physical. Data files, log files, parameter files, control files are physical. Anything that you can see with the operating system command is that we call physical. Anything that you have to log into the database, you want to see how many table spaces you got, users, tables, how many views, how many indexes, those are all logical, because you can't see it from the operating system. If you look at the diagram, there are segments, extents, and blocks. These are different grouping, and segment exists in a table space. Segments are collection of extents. Extents are collections of data blocks. Data blocks are mapped into disk blocks. So disk blocks, number of them makes data blocks. Data blocks, extents have multiple data blocks, and the segment has multiple extents. Blocks, extents, segments. Segment meaning something that can hold on to data. Table and indexes are segments. How is that segment stored internally? So what is common is this. Table has columns, rows, definitions, and an owner. That's not going to change. So what Oracle does, it says the way I manage segment is break them up into extents. What is an extent? It's a continuous chunk of blocks. How many extents a segment can have? It's unlimited. What is the smallest unit of I/O? A data block. The smallest unit of I/O, read or write, is going to be on one block. You cannot go smaller than that. If you want to go smaller than that, there's only one product that can do that. That's Exadata, which is recently available, when your IOs can be optimized on a column level. The table does not change, but the way we organize things may change depending on what vendor you're using, what storage you're using, etc. But this is a very common way of organizing storage, how blocks make up extents, extents make up segment, segment meaning tables and indexes are segment. Some of the files are mandatory, like system files, temp files, undo files. You can't run your database without them. So when your database is created, there are some structures that are already out there which hardly needs maintenance. They are not connected to tuning. The only thing your DBAs do is that they make sure that there's enough disk space so they can grow. So that's about the SQL Tuning Chapter 1.